Hello and welcome to another video in our series, where we dive deep into the world of enterprise maintenance. I'm Ryan Chan, the CEO and founder of Upkeep. Today, we'll be unlocking the intriguing world of vibration analysis, its applications across various industries, and how it's reshaping the way we approach predictive maintenance. We'll also discuss how vibration sensors are becoming a game changer in condition monitoring. Finally, we'll touch on vibration analysis certifications and their levels. So let's gear up to understand how these technological advancements can revolutionize your maintenance and operations teams. Let's dive into the exciting world of vibration analysis and how it's applied in various industries. First off, let's talk about diagnosing rotating equipment. You see, any equipment that rotates, like a rotor or even your car's tires, does so at a specific vibration frequency. When the equipment begins to unbalance, this vibration frequency changes slightly until it's completely out of balance. This is when the vibrations become noticeable, like when you feel them in your steering wheel because your tires are out of balance. But here's where it gets interesting. With vibration analysis and predictive maintenance, technicians can start to understand balance issues before they become big problems by looking at these small changes in vibration frequency over time. Spotting these changes can help us predict when we should perform maintenance. Now, let's move on to the operation of bearings and gears. Vibration analysis is not only useful for rotating equipment, but also for smaller parts of larger equipment, like roller bearings and gears. Changes in their vibration frequencies can indicate a failure that wouldn't be understood until the entire asset failed. Even in a non-rotating piece of equipment, vibration analysis can detect changes in overall vibration frequency that comes from failing bearings or gears. This means the applications of vibration analysis could be virtually limitless. But what about electric motors? Well, they can be tested with vibration analysis too, because they use bearings and rotors. Vibration analysis can detect a failure that would occur for reasons that aren't necessarily standard to electric motors. For instance, if a motor fails repeatedly, but the electrical components look fine, a maintenance team might be stumped to find the root cause. But with vibration analysis, it's possible to understand exactly why the motor is failing, despite being electrically sound. Now let's talk about some common use cases for using a vibration sensor in predictive maintenance. Vibration sensors trigger alerts in a CMMS system when a variety of conditions occur, like improper calibration of a motor, excessive vibration of a piece of equipment, or too much movement of system fans. Vibration often signals a potential problem within manufacturing and production facilities that can result in future breakdowns or shorter equipment lifespans. One study found that about 90% of machinery can benefit from condition monitoring, including vibration sensors. These sensors can play a significant role in your preventive maintenance program. Let's consider some real-life examples of how vibration sensors can be your constant set of eyes in your facility. Firstly, water pump monitoring. Vibration sensors can be placed on condensers or water pumps to monitor for excessive motion on fans, bearings, and motors. In the water and wastewater industry, pump problems can prevent customers from accessing clean water. Add that to the financial implications of pump downtime, and you have a serious case for using vibration sensors. Next, motors, gearboxes, chillers, and belts. If you're running equipment that functions with these components, you may benefit from using vibration sensors within the system. For example, in the food and beverage industry, problems within these systems can create a significant ripple effect throughout the supply chain. Data from vibration sensors can be analyzed over time to support excellent preventive maintenance systems. Then we have fan and compressor monitoring. Fans play a big role in industrial equipment as well as manufacturing clean rooms. HVAC systems also require working fans and compressors to stay up and running efficiently. Vibration sensors can monitor a myriad of assets, sending notifications when out-of-range occurrences are detected. Wind turbines are another great example. The rotor speed of wind turbines typically falls between 5 and 30 revolutions per minute. Vibration sensors work well in this industry because they can easily measure frequencies of both gear mesh and bearing defects. Once this data is returned to a main collection point, technicians can make scheduling and repair decisions. Last but not least, rolling bearings. These contact bearings are part of nearly every piece of rotating equipment. This machinery depends upon specific bearings as well as precision functioning of spacers, housing, shafts, and nuts. Although bearing fatigue was once the measure of failure, recent studies have found that less than 3% of failures can be attributed to fatigue. More commonly, bearings are contaminated, lubricated poorly, or misaligned, all of which cause vibration. Sensors, then, can provide the necessary red flag for preventive maintenance managers. Now, let's briefly touch on vibration analysis certifications. Vibration analysis involves the science of collecting and analyzing vibration patterns from equipment to identify potential failure points. This process involves various tools and techniques to come up with sound recommendations. Being certified in one or more levels helps build the confidence of performing proper analysis. Vibration analysis is ideally used for inspecting rotating equipment. These would include gears, bearings, and electric motors. Vibration analysis has been a useful tool in the maintenance industry, particularly in predictive maintenance strategies, because this field potentially involves a wide variety of highly complex and specialized situations. Certifications are broken down into multiple categories. Vibration analysis certification courses are available in categories of varying complexity. The basic, intermediate, and advanced vibration courses are referred to as Cat 1, 2, and 3, respectively. A master-level course category, Cat 4, is also recognized. The levels of vibration analysis certifications are designed to suit your level of experience. The typical minimum recommended work experience is at least 6 months for Category 1, 18 months for Category 2, 36 months for Category 3, and 60 months for Category 4. These may slightly vary depending on the institution that is offering the course. The recommended experience helps you to more easily grasp the concepts to be discussed. You may be allowed to still take the course, even if your experience falls short of the recommended minimum. However, note that you can only be fully certified after gaining the required work experience per category. Lastly, let's talk about the time commitment for these courses. The number of course hours varies depending on the certification category. Category 1 certification usually takes 30 hours to complete, while Category 2 and 3 certifications each take 38 hours to complete. Category 4 certification, the most advanced course, takes up to 64 hours to complete. And that's a wrap. Thank you for joining us today as we explored the world of vibration analysis, its applications, and the importance of vibration sensors in predictive maintenance. We also touched on the value of gaining vibration analysis certifications. Don't forget to subscribe to our channel for more informative content. If you want to learn more about how Upkeep can help your maintenance and operations teams, visit our website at upkeep.com. Until next time, keep learning and stay tuned.